So these two 1s orbitals are combining to make a sigma orbital. We can think about this as that the two orbitals are being added together, like in the equation we saw previously. We see that the molecular orbital that's produced is a bonding orbital. We know that it's a bonding orbital because we see that there is electron density along the bonding axis, so that the electron now is in an orbital that's shared over the whole molecule. We can also imagine what happens if we make the subtractive combination. So in this case, we can imagine both we can imagine subtracting the orbitals. So we have our 1s orbital, and if we subtract another 1s orbital, that is the same as adding a negative. So you remember that subtraction is adding a negative, and so if we want to make an orbital negative, that means we're changing the sign of the wave function. Okay, so another way is to change the shading. We're imagining a shaded and an unshaded version are coming together. So here, let's make this orbital shaded. Make my pen a little bigger here. Shade. There we go. Okay, so when we bring those two orbitals close together, we're going to get, if we think about where our atoms are, so we have one atom, two atoms. We're going to get, we see that anywhere that a shaded orbital and an unshaded orbital overlap, those are going to cancel out, and no electron density can be there, because it's like adding a positive number and a negative number. They cancel out. Okay, so what that's going to look like is an orbital that is unshaded over on this side and shaded over on this side, the way that we've drawn it. And we see that now there is a node, an area with no density in between the two atoms. So that means that the electron is not shared between the two nuclei. There's a node there, no electron density. So if you think about a bond as being an electron shared between two nuclei, then an antibond is an electron not shared between two nuclei. Now, even though the electron doesn't spend any time in the sort of internuclear space there, you can still have an electron occupying an antibonding orbital. And so it would just occupy the spaces that are shown here.